Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 41 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 40. But I must first ask, how many of you were successful? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you are not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, hopefully most of you guys were able to do this because this was just sort of exercising and working on the skills that we had learned in the last few lessons. Now, I think way back in this class in lesson number 13, I showed you how you could read a value from a potentiometer and then convert that value to a brightness and then control the brightness of an LED through a potentiometer. So we learned how to do the analog reads, we learned how to use the potentiometer, we learned how to write to an LED. All of those things we already know. But what have we learned in the last 2 or 3 lessons? We've learned about how to start doing modular programming or more sophisticated programming where we break our program into little logical chunks. We write chunks of code that we call functions, and then our main program is just calling those functions. Now, the first 2 or 3 examples we did were just more abstract, just with dealing things like grades or creating a list of grades and averaging those grades or sorting those grades or doing different things with those grades. But what I want to do today is sort of show you the use of functions when you're working with circuits or components on your breadboard, because that's really where we want to start using it. Because as we move forward, we're maybe going to be using more than one component at a time. Maybe we would want to use a GPS at the same time we're using a servo, or a stepper motor at the same time that we're using the accelerometer. We're going to want to start working with more complicated components and working with more components at the same time. So we need to start thinking about this structured, logical approach to programming where we break things down into manageable chunks that we call functions. The other important thing about this is that we're learning about how to use local variables, that we just don't have global variables for the whole program, but we start isolating our variables down to the little logical chunks, or down to the functions. And so we're going to be diligent to be more careful about using local variables instead of global variables. Okay, way too much introductory talk, and let's jump over here and get started. I'm going to start by kind of showing you my circuit. It's a pretty easy circuit. I also need to get out of your way. It's a pretty easy circuit, and what you can see is we have an LED on the breadboard and we have a potentiometer. And let's start by we establish the ground rail on the potentiometer by putting the ground rail on the breadboard by putting a jumper wire over to the ground pin on the Arduino, and then we establish a power rail here by running the wire over to the 5-volt pin on the Arduino, and then we have our friend the LED. The long leg of the LED is connected to the GPIO pin 9 over here, so we're going to to be controlling the LED through pin 9. It's one of those with a squiggly on it, so we can do PWM. And then the short leg of the LED, I'm going through a 1000 ohm resistor down to the ground. So the short leg of the LED goes through a 1000 ohm resistor to ground. The long leg of the LED goes over to pin 9. Now over here on the potentiometer, we have the right leg of the potentiometer hooked to the power rail, the left leg of the potentiometer hooked to the negative or the ground rail, and that center pin of the potentiometer is where we're going to make our reading, and we're coming over to the analog in pin A5. Okay, so that is our simple setup. You could use whatever pins you wanted. The potentiometer does need to be connected to one of the analog in pins. Okay, it does need to be connected to one of the analog in pins. And then the other thing is that the LED needs to be connected. It doesn't have to be pin 9, but it does need to be one of the pins that has the squiggly on it. That's a pin that we can do PWM on, if that makes sense. Okay, I hope it does. So let's just jump in and start coding. Now, it's easy enough to do this without functions, but we're getting comfortable with functions by exercising our use of functions on simpler programs. And so that's why I wanted to not do something too complicated here. Just trying to get you comfortable with the idea of using local variables and using functions. Okay, so let's go ahead. We're going to set up our pins, our GPIO pins. We're going to set those up as global variables because those do need to be known by all parts of the program, and we shouldn't have one function calling pin 9 one thing and another function calling pin 9 something else. So we'll make these global variables. So I'm going to have my read pin, and that is the pin that's connected to the potentiometer, and that is analog pin 5, as I said in the little picture above. Now we are also going to then going to have the LED pin, and what did I say that was? That was the pin 9, which is convenient because it is a PWM pin, so it'll allow us to do the brightness or the analog writes. Okay, now if we're going to have those pins, we are going to need to do some pin mode. So I'll do a pin mode on read pin. That's going to be an input. And then we will use our semicolon, and then the pin mode, it is the LED pin, and that is going to be an output. All right, so we've got our pins defined, we've got our pin modes done. Now we're going to come down and we're going to come to our void loop. Now we're going to start defining our variables that we will use in the void loop. So one thing is we are going to want pot val. Okay, that's the value that we read off the potentiometer. We're not going to give it a value, but we are going to declare it. That is a local variable local to the void loop. We're also going to need a bright val. Okay, we're going to need a bright val. That is the value that we send to the LED. So we will read from the potentiometer a number between 0 and 1023, and then we will write to the LED a value between 0 and 255. And again, I think it is lesson number 13 in this playlist, in this class, where I went in and kind of did this without functions. So if any of this is confusing to you, go back and watch lesson number 13. Okay, I have my local variable set up. Now, what do I want to do? I'm just going to now create some functions. Okay, I'm now going to create some functions. And so what I'm going to want to do is I'm going to want to come here, and then I'm going to want to have a function called readPot that will actually go out and read the value from the potentiometer and then return it to the void loop. And so where am I going to put that value? I will put it in pot val, which I just declared, and that is going to be equal to the function that I'm going to define, which is readPot. And then readPot is going to need to know a parameter. It's going to need to know where is that potentiometer? What pin am I supposed to be reading? Well, we need to pass it read pin like that. Okay, so then we should have a value from the potentiometer in the variable pot val. All right, now what I also need to do is I will write that. Let's go ahead and write that. Let's go ahead and write that that function now. Okay, let's go ahead and write that function now. So I'm going to come. The functions need to be below the void loop, not inside the void loop. So you see I'm here outside of the void loop, and so I'm now going to define that read pot. Now I'm returning a value, so it should not be a void function. I am returning a value. What type of value am I returning? An integer. Okay, an integer, because it's a round number that is read from the potentiometer. So it is going to be an integer. Now I need to catch that variable. I pass that the variable read pin, but where I'm going to catch it, I'm going to catch it in the integer pot pin. And I'm just showing you that these don't have to be the same variable, but the value of read pin will be passed to the variable pot pin. Okay, now I need to do an open and a close curly. Now I need to define, I need to declare my variables for this function. Well, I am going to have a read val. Okay, I'm going to have a read val, something that I am going to read. Now, how do I get read val? Read val is going to be an analog read of what? Pot pin. And pot pin comes from here, and it is sent by read pin. So remember, read pin was A5. Read pin is going to be passed to pot pin, and then read val is going to be read from pot pin. Okay, that all looks good so far. Now what do I want to do? I want to return read val. Okay, so it's going to take that read val, it's going to return it here, and then it's going to put it in the variable pot val. So let's just see. I think I'm going to go ahead and do a serial.println. I'm going to print pot val and just make sure that I haven't done anything silly this early in the program. So let's go ahead and run this. Okay. Looking kind of good, isn't it? Looking kind of promising. It is downloading now. I think this is looking really good. Did I do a serial.begin? I did not do a serial.begin, so I better come back over here. Serial.begin. And I'm kind of trying to start using 115.200, a little bit faster, so let's do that now. I'm not going to count that as an error because I caught it before the thing didn't work. So we're going to say my performance so far is flawless. Okay, it is going to be considered flawless. Okay, we'll come over here like this. Look at that. For some reason, it's not connected. Wow. Okay. For some reason, I had to unplug it and plug it back in, but let's see. Okay, now I think it's going to work. For some reason, I just lost my connection with the Arduino, but I think we're okay now. So now we're going to run this again. It is downloading, and we are printing 0. And so hopefully this is all the way to the left. And then as I come to the right, it starts counting up, and I should be able to go to very close to 1023 as I turn this to the right, and that will tell me that everything is hooked up. Yep, all the way to 1023. and then we'll go back to 0. So the circuit is right and that first function is right. So that's very, very good. Not very interesting, but we aren't done yet. So we have read the potentiometer, right? First thing we have done is we have read the potentiometer and put the value in pot val like that. Okay, now what do I want to do? Well, I have pot val, but I need to change that into a brightness value. Okay, and so I'm going to now say bright val, a new variable, bright val, which I define up here. Bright val is going to be equal to the return value from find bright, and then what do I have to pass it? I've got to pass it that pot val. So if it's going to find the brightness, it needs to know what the value from the potentiometer is. And since these are local variables, initially only the read readpot knew what read val was, but it returns read val back to the void loop and puts it in the variable pot val. So now the void loop knows pot val. We can print it, and now we can take that pot val and we can send it to the function we're fixing to write, which is bright val. Okay, and so let's come down here and similarly to our earlier function, this we're going to return a value. It's going to be an integer, so I'm going to say this is an integer, and the function is find bright like that. And then here, the variable that I'm going to use is PV. And what does PV stand for? That is where I catch the pot val. The value in the variable pot val is now sent down here, and it is caught in the variable PV, which is declared here in the function declaration. So hopefully that makes sense. But now I have the pot val. Now I need to calculate the write val, or the value that we are going to write to the LED, the value that we are going to write to the LED. So I'm going to call that BV for bright val, and that is going to be equal to PV. Now, I'll tell you the equation. We did this equation in detail in lesson number 13, but what we can see is our read value goes from 0 to 1023, and our write value goes from 0 to 255. So that's a very simple linear equation without a y-intercept. The y-intercept is 0, and so we can just do this particular one as a very simple ratio. How would that be? We would multiply it by 255 point divided by 1023 point, like that. And so let's just check this. If we are all the way at 1023 in our read, it would be 1023 divided by 1023, that's 1, times 255, which would be, we would write 255, and that would be maximum brightness. So it works for the maximum value, and then if we are reading a 0, the minimum value, 0 times this is 0. So it works for the low end, it works for the high end, it will scale linearly in between those two, okay? So we have that working now, so we'll go like that, and then we got that written. Then up here we have the bright val is equal to find bright. So now we have a bright val. Okay, now we have a bright val. So what do we want to do at this point? We want to set the LED. So I'm going to say set the LED, which is a function that we have not defined yet, but the set LED is going to need, if it's going to set an LED, it needs to know where it is. So I'm going to send it the LED pin, and then I'm going to send it the bright val. Why bright val instead of BV? Because BV was returned here, and it was put into the variable bright val. So the void loop thinks of that as bright val, and the function thinks of it as BV. So it's the same concept, but we're using different variable names local to their individual scopes. Okay, so now I have that. So I set the LED, and it's going to need to know the LED pin, and it's going to need to know the bright val. So now I'm going to need to declare that function. I'm going to need to define that function. But notice this doesn't return anything. This is just going to send the number to the LED, but it's not going to return a number back up to the void loop. It doesn't return anything. So I don't have something equals that. No, because it's just going to go there and it's going to do a task for me. And since it's not returning anything, what type of function is it? It is a void function. It doesn't return anything. So we are going to call it void. So it's going to be void set LED, and then it is going to get the LP and then the int BV. And so what is LP? LP is the LED pin and BV is the bright val. Okay, so now I have those two things, and then I am going to put in my curlies. All right, and then what does this function do? It does an analog write of LP, and BV. So I write BV to the pin LP. All right. Now, what you guys might say is, you don't need functions to do this. This is an easy enough program. Yeah, but what I'm trying to do is I'm trying to get you comfortable about how to pass parameters down into a function and how to return values from a function, so that those basic operators of how to weave your functions together with your main program, you'll know how to do that. Then when you get to something real complicated, you can kind of have the skeleton or the framework of the program. You really understand how to make it work. Then you can go in and you can define more complicated functions because you know how these things fit together. Okay, I hope that makes sense. So let's come up here. Let's see if this thing runs this time. So, hey, what is that? BV? What is that? It didn't like BV. Okay, what did I do there? Knows what PV is. I didn't declare BV, so int BV. PV, it knows, has been declared here, but I have to declare BV, just like I declared read val up here. Okay, let's see if that works now. Still doesn't like that. Who's your friend, Mr. Semicolon? All right, let's try. I think it's looking good this time. Okay, done compiling. It is downloading into the Arduino, and we're going to come here and turn on the serial monitor. Okay, we've got a 0. So what do we see? That I'm all the way to the left. I am reading a 0. Man, let's put in our before I try this, let's put in another print here. So I am printing the bright val. Okay, I'm printing the pot val, and I'm just going to do a print, and then after I get bright val, I'm going to print that. So I'm going to do a serial dot print, but I'll print a separator, so I'll print a comma like that. Then I will do a serial dot print, and I will print what? The bright val, so I can kind of see what's going on, if it makes sense what is happening. Okay, let's try this again. I'm going to come like this. Okay, that is looking good. That is looking good. Okay, downloading, and got 115,200. It looks like it doesn't 115,200. I'm not sure why it doesn't like that in the serial monitor. Oh, I never did a print ln. Okay, so I did a print, and that next one needs to be a print ln. Let's try this again. I think it should work this time. Okay, it is downloaded, and so you see that I am reading from the pot value as 0, and a bright val is 0, as we would expect. Now as I begin to turn up, this is most interesting, as I begin to turn up the potentiometer, it's not reflected in the bright val. And so we have an error in here. Hopefully you guys saw what my error is. So I am printing bright val, and I am finding bright from pot val. And so on find bright, I have bright val is equal to pot val times 255 divided by 1023. But what did we not do? We did not return bright val. We did not return bright val. Okay, so we calculated it. Find bright knew what it is, but we returned nothing, so this bright val had no value. That one kind of scared me. I really was not expecting that, but I can clearly see what my error was. Okay, so we'll run it again. Okay, so we got 0, 0, and now we come up to 8, and I've got a 1. Okay, and can you see the LED starting to come on? Yeah, okay, so we go, and that's going nicely, very nicely, and all the way up to 1023, and it's writing 255, and that is full brightness. Now, you know it's kind of hard to film the LED. You guys know that, but I can tell you when you look at it with your naked eye, it looks really good. Okay, and you can see from the values that we're printing, it's behaving as we would expect. But now this is what you have to see, that as I'm turning this, I turn it like halfway down before I see any perceivable dimming. And then once I'm about halfway down, then it dims very, very rapidly. So here on the low end, just a tiny change in the potentiometer, and I can very perceivably see a difference in brightness. But then it seems to saturate at about halfway, and halfway to full, there's no perceivable brightness. Now, we talked about this problem in lesson number 13, and that is that we are turning the brightness up linearly, but your eye does not perceive brightness linearly. The brighter something gets, the more it has to change in order for you to perceive the brightness. So really, if we wanted this to work very elegantly, we would not, if we wanted it to work very elegantly, we would not be at all wanting to use a linear scale. We would want to use something more like an exponential scale. Okay, something more like an exponential scale. So you see, what we are doing is we are right now, let me make sure here, we are using a linear scale where we are kind of turning it up from 0 to 1 to 2 to 3 to 4. And as we do that, we can very clearly perceive the change in brightness. But when we come out here to like 250 to 251 to 252, here these jumps we cannot see at all. And so this linear scale just doesn't work. So we want, instead of with every increment adding 1, we want an exponential scale where with every increment we double it. And so we want to kind of start with, imagine like a 1, and then we want to go to a 2, and then we want to go to a 4, and then we want to go to an 8, and then a 16, and then a 32, and then a 64, and then a 128, and then a 256. Now, if we did this, this would then, our eye would perceive it as a nice, smooth, linear increase in brightness from all the way to the left to all the way to the right. Well, what do I mean by exponential? Well, a 1 is 2 to the 0. So in fact, any number raised to the 0 is 1. Just one of those things you have to say, like 27 raised to the 0 is 1. So any number raised to the 0 is 1. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 6 is 64, 2 to the 7 is 128, and 2 to the 8th is 156. So we want to increase our right value, or our bright value. We want to increase exponentially like that. Well, what does that mean? Well, if we had that, what variable were we using over here? I think we were calling it pot val and bright val, so BV and PV. And so what we want is we want the bright val to be equal to 2, which is this 2 here, and 2 raised to the what power? Well, if we raised it to PV, or pot val, that would be raising it too much, because it would be like 2 to the 1 is good, up to 2 to the 8 is good, but then 2, 9, 10, 11, 2 to the 10, 23, that gets much too big. So we've got to scale that PV back. Well, how do we scale that PV back? Well, what we know is we know that when the PV, when the pot val is 1023, we want the bright val to be 256. So when the PV is 1023, we want the bright val to be equal to 2 to the 8th, like that. Okay. Now, what that means is that we need to take the PV here, and we need to divide it by some constant that will give us 8. So what that means is we want 1023, the PV max, divided by this constant is equal to 8. Let's multiply both sides by C. So then we would have 1023 is equal to 8 times C. And then C would be equal to 1023 divided by 8. And then that is going to be equal to, I think I have that written down here, that is equal to, put it in your calculator, 127.875. Okay, so that is our constant. So now what does our equation become to calculate the brightness value? The brightness value is equal to 2 times the potentiometer value divided by 127.875. Okay, this is the equation. All right. Now, let's check it. If PV is 1023, 1023 divided by 127.875 is 8, and 2 to the 8 is 256. So at maximum pot val, I am going to write the maximum LED value of 256. Okay, and we'll take care of that off by 1 here in just a minute. So let's see, there's 2 little things that aren't perfect, and one is the maximum value that we can write is 255, not 256. So this little algorithm is 1 too much here, right? This is 1 too many, and also all the way to the left, when the pot val reads 0, we don't want to write 1 to the LED. We want the LED off, so we want to write 0. And so how could I fix it? If I subtracted 1 here, that makes this one work. If I subtract 1 here, that makes this one work. And so really what our equation that would work perfectly would be that the brightness value is 2 raised to the pot value divided by 127.875, and then that whole thing minus 1. And now if we do this one, it should work very well. Okay, so write that equation down, and let's see if we can get this thing to work even better. Let's see if we can get this thing to work even better. So we're going to come back over here, and then now I'm just going to change this, right? Because my brightness business is taken care of in the function. I don't have to mess with my main program. My main program is I read the pot value, and then I calculate the bright value, and then I apply the bright value to the LED using set LED. You see, it's just all there what I need. But now we're going to dig in here to this part of the program, and we're going to come up with a more elegant solution. So I'm going to comment that one out, and then I'm going to put our new exponential function in there. And what that is bright val is equal to 2 raised to the. Okay, how do I do a 2 raised to the? It is the power function. The power function where I'm going to take 2 and I'm going to raise it to what? It was PV divided by 127.875. Okay, it was raised to that. Okay, then that closes the division, that closes the power, and then that whole thing minus 1, like that. Okay, so now we're still going to need our semicolon. Let's go ahead and try to run this now. Okay. It is downloading, and no errors. That's good. Okay, now this is interesting. We're going to come back. The left is the pot val. So when I have a 0 pot val, I have a 0 right val. Now let's look over here, and I'm going to come up here where you can see this a little bit better, hopefully. Okay, now I'm going to begin to turn this up, and then what you can see is you can see the LED very, very smoothly turning on and very smoothly changing brightness, and then all the way over to full bright. Now when I'm over here at full bright, if I back off a little bit, even a little bit, you can perceive it. So I can perceive small changes on the top end, and I can perceive small changes on the bottom end. You see, I can perceive those small changes on the bottom end, and I can perceive those small changes on the top end. So this is a more elegant and a more visually appealing way to dim the LED. But do you see what the power of this is? It's all done down in the functions. Now, do I want to, every time I want to play with an LED, do I want to come back and do this equation again and try to remember how I did that? No, I don't. What I want is this nice little chunk of code. What I want is this nice little chunk of code here that I could save and I could use it in the future. It is a function that will take a pot val and calculate a bright val that will allow you to very perfectly control the brightness of an LED. Okay, guys, I hope this has been good practice for you, and I hope that you've been able to get a little bit more comfortable using functions, why they're important, and also get a little bit more comfortable of how to pass parameters, how to pass local variables and local parameters down into a function, and then how to return parameters or return values from the function back to the calling routine. Okay, so hopefully that makes sense. All right, guys, we have spent a few lessons sharpening our programming skills. We've learned about global and local variables. We've learned about arrays. We've learned how to define functions with global variables, now functions with local variables, and then kind of a realistic project where we have functions with local variables using components on our circuit board. So hopefully that has been useful, and as we move forward in this class, we'll be using functions more and more as we get to the more sophisticated components in the kit and as we get to more sophisticated programming tasks. So what we're going to do next week, we'll get into a new component, so we'll start going back a little bit more, doing some lessons on hardware and breadboards and circuits, and then eventually we'll come back and learn some more programming skills. So I just like to do a little hardware, do a little software, advance your hardware skills, advance your software skills, and then eventually we'll get through all of these exciting components in your kit. I hope you guys are having as much fun taking this class as I am making it. As always, I want to give a shout out to my supporters on Patreon. It is the Patreon members who are keeping this great content coming. It is your support that allows me to keep making this great content. Thank you. You can also help me by leaving me a thumbs up on this video or leaving a comment down below. Also, if you haven't already, make sure you subscribe to the channel. When you do, make sure you ring the bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.